Hello math fans, we're going to be talking about geometric series in this lesson. As always, be ready with your pause button so that I can go quickly. Alright, speaking of pause, you might want to pause this to read more carefully. Otherwise, I'm going to go through this quickly. It's a quick review about sequences where we talk about how a sequence is a series of numbers that follows some sort of rule. Maybe we add by 3 every time. Maybe we multiply by 3 every time. Maybe we square the number every single time. Whatever it may be, a geometric sequence is one where we're multiplying by the same number every single time. That number can be positive or negative. It can be a whole number or a fraction. And so as long as we're doing it throughout the sequence, we're obeying the rules. That number is called the common ratio, the one that we're multiplying by the entire time. So we can usually just take the second term and divide it by the first term if we know that it's a geometric sequence. If it's not, if we don't know that, then we have to go ahead and show that by dividing all the consecutive terms to see that we get the same number, the same common ratio. And finally, we're going to focus just on finite sequences. So they have an end. They don't go off to infinity. So we're not going to find the sum off into infinity, for example. So that would be for another lesson. So let's move forward. A finite geometric series. The difference between a sequence and a series are the plus signs, essentially. In a sequence, you have numbers separated by a comma. And in a series, you're going to add up those terms, the terms of a sequence. Okay, and so that's the main difference. So if, for example, I wanted to find the sum of the first 7 terms of a geometric sequence, then I would write this. So this would be the geometric series where we add the first 7 terms. All right, and so this would be a geometric series with the capital S where we're adding the first 20 terms. Okay, now there are 2 formulas that help us do these calculations, and if you look closely, these 2 formulas are actually the same. The only difference is we've taken the first one and we have rearranged it a little bit to make the second one. And the reason why that might be, I would like you to go ahead and pause and see if you can figure that out. Also consider the other question, what happens if r is equal to 1? Okay, the answer is that if r is greater than 1, then we like to use this formula, this version of the formula, because if you look at r, if it's bigger than 1 and we subtract 1, we're going to get a positive number. So we're going to get a positive number here and a positive number here. As opposed to if we use this version of the formula, we would still get the correct answer, but we're going to be dealing with negatives, because if r is bigger than 1 here, we're going to get a negative number here, and we're going to get a negative number here. So just to make things more positive, we have 2 different versions. So, and you don't have to memorize which one to use when r is bigger. You can just look at to see which one would make the denominator positive. All right, if r is bigger than 1, then this is going to be positive. If r is smaller than 1, then this is going to be positive. Okay, let's go ahead and try an example. But before the example, I've just thrown this in really quick just to show you where that formula comes from. You don't have to know this, but if you want to go ahead and sort of puzzle your way through this for a while, it might help you really understand where this formula comes from and really how it works. Okay, so for deeper understanding. Now for our first example. Go ahead and try this example, press pause, and then we'll take a look at the solution. Okay, so we have this geometric sequence, and hopefully you've determined that the first term is 3, that the common ratio is going to be 9 divided by 3, which is 3, and we're looking at the first 6 terms, so n is going to be 6. So we take our formula where r is bigger than 1, so we're going to use this version because 3 minus 1 is going to be positive. So we're going to just substitute these numbers that we know into this formula. So the first term, u1, is the first term, it's 3, put that there. The common ratio is also 3, because 9 divided by 3 is 3 here. N is 6. and then we go ahead and complete the formula. So now we have to begin simplifying. So we look inside to our parentheses, we do this exponent first, so we get 729. Then we simplify inside the parentheses, and we get 728. We're going to multiply that times 3, so we get 2184. The denominator simplifies to 2. So it turns out that the sum of our first 6 terms is 1092. Hopefully you got that. Okay, well, what if you would have used the other formula, the other version of the formula? Well, I think you'll see that you'll still get the correct answer, 1092, but what's going to happen is you're going to get a negative number up here in the numerator and in the denominator. Those negatives are going to divide out and become positive, and so you're going to get 1092. So you'll still get the same answer, so you don't have to stress about if you're using the right formula or not. It's just that one of them will be a little bit easier since you won't have to deal with negatives. Okay, earlier I asked the question, well, what happens if r is equal to 1? And I don't know if you came up with an answer for that, so I'd like you to go ahead and try this, this little experiment where the first term is 5, and then the common ratio is equal to 1. Go ahead and write the first 5 terms and find the sum of the first 7 terms. Okay, hopefully the reason why r equals 1 is an interesting case should become evident quickly. So it means that you're multiplying the first term times 1, and then times 1, then times 1, all the way across to generate your sequence. So really we have a sequence of 5s. So just to find the sum of the first 7 terms, you would just be adding 5 7 times. That's 5 times 7, which is 35. You don't need a geometric series formula to calculate that. So that's the reason why we don't consider when r is equal to 1. Okay, here's another example. Go ahead and pause and try this, and then come back for the solution. Okay, so we need to start figuring out pieces of the puzzle so that we can substitute it into our formula. So the first thing we should recognize is the first term is 20. It tells us it's a geometric sequence, so all we have to do is take the second term and divide it by the first term, which is negative 1/2, so that gives us the common ratio. And we want to find the sum of the first 10 terms. So we take this information and substitute it into our formula. Again, because r is less than 1, I'm going to use this version of the formula. Now, things are going to get a little bit sticky because we've got fractions and we've got negatives raised to powers, and so you need to keep these straight. Basically, this is a test of how well you can type problems into your calculator. And the most important thing to do is when you realize that r is equal to negative 1/2, you need to put that negative 1/2 inside of parentheses. Alright, so it's going to be 1 minus, and then r, which is negative 1/2 to the 10th power. So you need to type it like this. And again, r's to the negative is negative 1/2, so we need to keep it inside of parentheses like this. If you do that, then the rest of the problem should come out correctly. All right, you do some simplification along the way. I went ahead and did this all with fractions so that you can see what the final answer in fraction form looks like. You don't need to be able to report it like this. You can actually just report the decimals. So you could have converted all these into decimals. Just make sure that you're carrying all the decimals into the end. So this has been rounded off to 3 significant figures. Okay, so I think it's important to note that there's a difference between typing this and this. Now sometimes you're going to get the same answer, and it'll just be lucky because you will get the same answer when the exponent is odd. If the exponent is even, then you'll get different answers. So please be careful. Practice typing into your calculator, as silly as that sounds. Now off to our final example. Go ahead and press pause and try this problem. Okay, so we should write what we know. We know that the first term is 300, that the fourth term is 153.6. Now we're going to have to go back to our formula with sequences that tell us that the fourth term is just the first term multiplied times the common ratio 3 times. And if we substitute this information into this formula, we can see that we have all the information we need except for r. So we have to do some algebra. We have to get r by itself. The first thing we can do is get rid of this 300, divide it on both sides. We can simplify the exponent to being r to the third power. And on the left side, we can go ahead and divide this out in our calculator, and it should equal a number like this. Then the final step, to get rid of this exponent of 3, we have to take the cube root, the cube root of both sides. So this just becomes regular r, and then you type this into your calculator and you get 0.8. So we did all of this to figure out what r is. Now that we know what r is, we can go ahead and use our series formula. So our series formula, the one that we're going to use, again, since r is less than 1, we're going to use this version, and we can substitute all the information in. We know what u1 is, we know what r is now, so we put those numbers in, and as long as we're being careful about how we're typing things in, we should get 1338.94. I just went ahead and put the exact number there instead of rounding it to 3 significant figures. So this should be okay. So hopefully you got that, because if you can get this, then you should be able to get most of the the challenging series problems that are out there. So hopefully you found this video helpful. Give me some feedback and let me know how it worked for you.